Okay, let's go ahead and get started. Hold on, I have something official here. So the whole schedule thing, that whole schedule issue was so messed up. I posted the new one for the version 10 online and then found out that that was messed up. So look, right here, officially right now with the stamp on it, this is the official schedule. If you go to Canvas right now, it'll say new schedule. There's only one link to a schedule, new schedule for both books. That's what it says. So what this schedule is it's the date, it's the section, and then there's two columns, one for the 9th edition, one for the 10th edition. And then what you can do is just scratch out, if you're 10th, just use the one on the right. If you're 9th, just use the one on the left. And then there's no confusion. There's not two versions of it floating around. You do not have to redo anything. No. No, because the problems are similar enough that...
Okay. So if like we start on like 1.4, we just continue with the original?
Yeah, just stick with whatever you're doing.
Okay.
All right? There you go.
Oh my God, no wonder the homework assignment was so...
Well, it should all be about the same. It's not like it was so different that you were completely, I don't know. Okay, extra, well, keep it just in case other people show up or something. Okay, so I know I had a question, and why don't you tell me what the problem is since we don't know what book you're using anyway, so.
It's 1 over x plus 1 squared equals 1 over x plus 1 plus 2.
Separately,
Yes.
like this. All right, it's a good problem.
I couldn't clear it. I didn't get that one.
Okay, so let's take a look at this. The name of the game here is to simplify, right? They're asking you to simplify this. So anytime we see a rational expression like this, what we want to do is try to clear out the fractions, clear the denominators out. And so what we need to do is look at all the terms, and I'm going to rewrite this 2 as a 2 over 1. So you have to view that 2 as being a fraction. And then at this point, you can find the LCD, the least common denominator, which would be x plus 1 squared, or in other words, x plus 1 times x plus 1. So the least common denominator comes from the fact that this denominator has 2 factors of x plus 1. So that means you need every single one of these to have 2 factors of x plus 1 in them. So I'm going to rewrite the problem. I don't have to do anything to the first fraction on the left side. That already has what I need. This one, I have to introduce another factor of x plus 1 next to this. So it's like I'm doing this, I'm doing an x plus 1 here, and then on top I'm doing an x plus 1 there. And then on this one, since I don't have anything but a 1, I have to do an x plus 1 squared and an x plus 1 squared on top. So I've introduced two 1s, in other words, to make this happen. So on this fraction here, when I put the denominators together and multiply them, I get the common denominator. On the top, I do 1 times this, which is itself. And then here, I get 2 times, oops, I forgot to put the plus between it. 2x plus 1 squared over x plus 1 squared. So I'm showing you one approach to this. This is just getting common denominators and putting everything together. Now at this point, can I add these two together? I could, right? They have the same denominator. The key, I guess, at this point would be to understand that you have an equation. And because you have an equation, remember we talked about equality, and you can always do something to both sides, right? You can always do something to both sides. So I found an LCD, since these all have the same denominator now, I could multiply through by that common denominator. So what would happen if I take this expression, x plus 1 squared, multiply it right here? What would happen to the x plus 1 squared that would be up here and the one that's down here? They would cancel. And what would happen if I put that x plus 1 squared and I multiplied it here? Cancel. And then here? Cancel. So that's how we actually clear the fraction. We actually just come through with the LCD now. So I'm gonna now multiply everything by the LCD. So LCD on the top here. Whatever I do on that side, I have to do to this side. So I multiply. I'm trying to squeeze it all in one place here. X plus 1 squared here, and then whatever I do there, I have to do here also. So does everyone agree that what I've done is I've hit each term with the LCD? Hit meaning multiplied. And it's on the top, not on the bottom. When we say we multiply through, it's on the top. So this cancels, this cancels, this cancels. And what you're left with is what? Over here? What do you have? 1 equals, the only thing left here is x plus 1. And then over here, plus 2, and then the quantity x plus 1 squared. And what type of what type of equation is this? It's quadratic. It's a quadratic equation. So we see that because this is x plus 1 squared. But see, there's no more fractions. No more fractions. So we can proceed in solving this. Are there questions?
You can also do substitute u, right? At the beginning.
Yeah, well, I guess so. What did you do? U is x plus 1?
U is, yeah, 1 over.
And then you did 1 over u squared equals 1 over u plus 2?
I actually did the whole thing. 1 over x plus 1 is u.
1 over x. Oh, okay, I see what you're saying. Oh, you could do that too. That'd be pretty clever.
Okay.
Yeah. Yeah. Okay, so now I'm going to finish this. You square this, right? So you have to do FOIL, which is this. If you multiply these two together, you get x squared plus 2x plus 1. Right? I'm just looking at this over here. That's what that's equal to. So if I replace this right here with this and then distribute a 2 through it, right, because I have a 2 out front, the 2 hits each of those pieces. So my new equation would look like this. I'd have 1 equals x plus 1 and then plus the 2 through that thing, 2x squared plus 4x plus 2. Are there questions? No? And now that's a quadratic equation. You think you could get it from there?
Yeah.
Get everything to one side? Okay. And then solve for x. Any other questions on the homework?
Number 83.
83, which, let me see what it was. Okay, just you can read that out to me then. It's x cubed.
X cubed minus 3x squared minus 4x plus 12 equals 0.
Okay, we didn't get a chance to look at this at the end of class. So I was thinking that I might have some questions over this. This is not a quadratic equation, and it's not even a quadratic form. Remember, we ended class last time. What we were doing is we were noticing that we had equations that kind of looked like quadratics, but we had to like make a substitution. Yes? Okay, so this one does not qualify for that. And the reason why is because quadratics with that substitution usually had 3 terms, right? It was usually 3 things. It was like ax squared plus bx plus c equals 0. So there's always 1, 2, 3 terms. Then the variable here, if we doubled the power, you get that variable here, and then we had a number by itself. That was what quadratic looked like. This one has 1, 2, 3, 4 terms, so it's not going to qualify for quadratic form no matter what. So this is a four-term expression on the left-hand side, which we're going to try and factor. And so this is just a matter of whether or not you remember how to do this. If you remember whenever you were taught, if you were taught. So anyone remember how to try and factor 4 terms? Grouping. Okay, does grouping ring a bell?
Yes.
What you do to factor by grouping is you look at the 4 terms. It's usually good to put them in descending order, so like highest power of x down, which is what we have. And what we do is we split or we partition the expression into two pieces. Right after the second term, right after, not after that minus sign, right after the second term, we split the expression and we look at the first part and we say, can we pull a common factor out of just these two? So is there something that can come out of just these two? X squared. So if I factor an x squared out of the first two, what would be left here? X minus 3. Right? So does everyone agree? We distribute this through, we get back this. Now you do the same thing on the next one.
Do we change the sign, or is it just a negative to group it? Or?
Well, it depends. You want to look at these two and pull out a common factor, right? You could say 4, right? Now this is important with grouping. If I'm going to say 4, I need to put plus 4 here. I can't just put 4. So I'll get to the negative 4 in a second. I'm going to try plus 4. If I pull plus 4 out, what would I still have in here? Negative x, and then a plus 3, right? And then equals 0. That's what would have happened had I pulled a positive 4 out of both of those, yes? But that's not going to work because for grouping to work, you need what's left here and here. These need to be identical. And they're not identical, they're off by a sign. So instead of pulling out a positive 4, we pull out a negative 4. And now if we change that, make this a minus 4, it changes this to a plus and it changes this to a minus. And that's what we need for grouping to work. And then we just say, okay, these two match, right? And so at this point, who wants to tell me what my next line should read?
X squared minus 4.
Okay. Okay, I heard x squared minus 4, and then in parentheses x minus 3. Right? Do you all agree with this? How many of you would have done it the other way and done x minus 3 times x squared minus 4? Anyone that would have done it this way? Yeah? Okay, they're both the same. Okay, it doesn't matter. But I have a deeper question for you. Why is it this? Because a lot of people, they're taught, okay, once you see this, then all you do is you write the two things in front, and then you write that by itself, right? But do you all understand what you're actually doing here? Yes? Okay, someone tell me. You're shaking your head, Giovan. That means I'm calling on you.
Okay.
Shouldn't have shook your head, I guess. Sorry.
Right, because the stuff that is in on the parentheses is the same. So
Yes.
you just group them together. Well, not group them together, but put them as one, I guess. And the ones that are outside the parentheses, you get them to. I don't know how to explain it, but
That's right, because it's difficult to explain because I think a lot of people are just told to do it and not really understand what they're doing. This is an important thing, yes.
Because it doesn't matter, because it's the same.
It is the same, but why do I get rid of the minus sign and or why do I just throw these two together and then just throw that one? Why is there only one of them, not two of them, right?
The terms are outside of the parentheses, and the parentheses are what is in there is in there.
Yeah, I don't know. I don't know if I'm sold yet. So let me explain it.
Because you're factoring the x squared minus 4.
You're that other way around. You're factoring the x minus 3 out. So watch this. A lot of people can do this pretty easily. All right, if I write this down and I ask you to factor something out, what would you factor out? A y. So you'd pull the y out, right? You'd be left with what? X squared minus 4 equals 0, right? That's what you would have? Okay, this is the same exact problem as this one, except that this is like a big y and a big y, right? And so what you're doing is you've got x squared y minus 4y. You're pulling a y out. The y for us, though, is actually this, right? So that y is sitting out here, and then what's left? This and this. So if you distribute this whole thing, if you distribute it through to that x squared, you get this. This to this, you get that. Do you all see that?
Yeah.
That's what's happening. So see, how many of you would have written it this way? Almost all of you. See, that's just because you were told to write it that way. If you actually are factoring something out, you'd probably do it this way, if that's the way you were told. Because, I mean, but they're the same thing, but just please understand that whenever you see something like this, you're just taking advantage of factoring it out. That's all you're doing. It's not magic or anything. Okay. All right, so just clarify that. Now, at this point, you set these factors equal to 0. So you set x squared minus 4 equal to 0. The other equation, x minus 3 equal to 0. Oh, wait a minute. I could have gone further with this. Difference of squares. Could have done x plus 2, x minus 2 equals 0. This one's just x is 3. And then this one you get two answers, negative 2 and positive 2. Right? So we have 3 solutions. You do not need to check these. So I have a question for you. In this problem, right here, starting this right here, we'll just start over. If I wrote that like that, and let's say I change this 12 right here to an 8. Okay, you see where I changed it? Everything else is the same. Then you still factor out an x squared here, be left with x minus 3, right? And you could still factor a negative 4 out, and you'd be left with what? X minus 2. Now, can you do grouping here? No, because these don't match. Do you see why now? You can't pull something in common out if they're not common. So grouping won't work. Maybe there was something else I could have pulled out that would have given me a minus 3 here. It's not going to happen, right? So in most classes, in an algebra class, in the past, you would have said this is not factorable. But we will actually have a way this semester to factor this. We're just not there yet. All right, so grouping always relied on us being able to get these to match. If they don't, we stopped in the past. Not anymore. But that'll be an entire day or entire week that we spend doing that. Okay, you ready to get started? Let's get back into the business of today. So I have your quizzes from last time, and does anybody? Well, you know what? I'll pass these. I'll come around and pass these out to you. Please sign in for today. Is Brennan here? I think Brennan is not going to be here. He's never been here, so he's probably, if Brennan is a guy's name, I don't even know. So please initial next to your name. And I accidentally put a green line through today, right? Today's the 2nd, but just initial over the green line, right? For some reason I thought September 2nd already happened. All right, we have some new stuff. So we have our notes. I am going to say I'm officially done with what was it, 4.1? 1.4, sorry. So we're done with the solving equation thing. All right, so we're going to talk about functions. Can everyone see the board okay? Suppose x and y are two non-empty sets. So we have a set, think of a set as like a basket. You've got two baskets, we're calling one x, one y. And they're non-empty, meaning that they've got stuff in them. A function from set x into set y is a relationship or a rule which associates with each element or number in x exactly one element or number in y. That's the kind of formal definition of what a function is. It's a relationship between numbers. So you start with one basket here. This is our set x. This is our set y. And then for each of these things in this set x, so those are numbers, we assign to it something over here in this other set, y. So x1 here goes to y1. Where does x2 go? Where does x2 go? Can you see where x sub 2 goes? No one has said it yet. x1 gets taken over to y1, right? Where does x2 get taken? To y1 also. Where does x3 get taken? To y3, right? It's a little 3, it's hard to see it. So there's no y2. Actually, y2 is the same as y1. So my question to you right now is that okay? Can a function do that? Can a function take two different values over here and send them over to the same place over here? Yes. What cannot happen is that you cannot have a number here go and get split off to two places in the y's. So that's kind of subtle in the definition, but it says here, it's right here. A function from set x into y is a relationship which associates with each element or number of x. So for each of these, there is exactly one number in y that corresponds to that. So does x1 go to exactly one place? Does x2 go to exactly one place? Does x3 go to exactly one place? Yes. Now, I want you to contrast that with this picture, which I'll do on the board. If I call this x and this y, and I have a point here x1, and let's say I have a point here y1, and I have a point here y2, would this be an example of a function? No, it would not, because to be a function for every point here, we have to assign exactly one point there, and this gets assigned to two different places. So this would not be a function. All right? A function from x into y. Curious though, what if I switch the wording around a little bit? I said that this would not be a function from x to y, would it? Right? What if I asked you, is this a function from y to x? Yes. Now that will become important later, because when you go this direction, if we call that f, then going the backwards direction will be called the inverse function. And so sometimes we want to know, does it satisfy being a function in both directions? If it does, then that's an important property. So, okay, so that's an example of something that is not a function from x to y. All right, now the next thing, the domain of f, okay, domain of f, which we will abbreviate in class. A lot of times you'll see me write dom f. That means domain of f. And the definition of the domain of f is basically the set x. All right, the set x. Everything that lies in that basket. But those numbers that are in that basket have to be able to be evaluated. The function has to be defined or make sense for those values. So we'll get into some examples. You'll see what I'm talking about. Now, the value of a function is, if you're given an x, so I'm given some x value, see this x3 right here, x sub 3. So we're given an x in the domain. The value of the function at x is the y which corresponds to it, denoted f of x. So you see how this x sub 3 gets sent over here, and we're calling this y sub 3? That could also be called f of x sub 3. So this notation with the x sub 3 in parentheses next to the f, that denotes a y value. Anytime you see an f and then something plugged in, that's a y value. That is in the domain or range. Or sorry, we haven't said range, sorry. That's in the set y, right? So this next topic, range, this is somewhat confusing. So be careful with range. A lot of people think that the range is that basket y. It's not, all right? So I'm going to give you an example over here. Let's say I have a basket that's filled with all real numbers. How do you say all real numbers? Have y'all seen this before? A double struck R, that means all real numbers. Y'all okay with that? That means everything that we know. All right, and then over here, let's say that this is all real numbers over here. And so let's say that I define a function that goes from that basket into this basket, and I'm just going to say it's the x squared function. So where would the number 1 get taken to? 1 squared would come out over here, and that would become 1, right? Where would 3 go? 3 would go to 9, right? 5 will go to 25. Where would negative 2 go? 4. Okay. So look at this over here first. The domain of this function is everything in here, right? Can you square every number? Yes, you can always square a number. All right, now over here, the basket y, okay, so this is my capital Y, is every number, right? But is the basket y everything that comes out of this function? What is in this basket that never comes from anything over here? Give me an example of something that's in this basket that does not come from over there. Any negative number, right? Any negative number. Think about this. Negative 4, is that a real number? Yes, that's a real number. But is it possible for me to get something over here and hit negative 4 with? I can't get to negative 4, can I? Unless I put imaginary numbers, but remember we are not going to deal with imaginary numbers. So here to there, can't get to it, can I? So the range of f, if this is my function f, the range of f is actually a smaller set than y is, isn't it? It's inside of y, but it's not all of y. In this case, it would just be what? Positives and what? Zeros in there too, right? Because you can get to 0, can't you? 0, 0 squared, 0. So the only thing that's in the range, I'll say the way we denote range is ran f. The range of f is just the positives and 0. So there's stuff in here that's not in the range. Understand the difference between the range and the actual set y. It's not the same thing. Sometimes it is, but it's not always. Sometimes, I know there are some people who are going to do a little more math. What we do is we say that here's the domain, right? And then f takes this over here, and instead of calling this the range, there's another terminology for it. We call it the image of f. And think about it. It's the image. It's what f does to this, right? It takes it through here and projects it over here and creates an image. And that image is the actual range. And sometimes that image is everything. Sometimes it's inside. All right, that okay? Yes? Okay. So the range is the set of values corresponding to all elements in the domain. The range can be all of y or a subset of y. So determining if y is a function of x. So if someone gives you an equation that has two variables in it, x and y, we can actually determine whether or not that defines a relationship, if the relationship defines a function. And the way we do it is as follows. So let's see. What we'll do is we'll check to see, right, if as you plug in values of x, you get one and only one value of y. If this happens, we say it's a function of x. Further, we call x the independent variable and y the dependent variable. And here's the notation we'll use. So we're going to do a couple of examples. That's a repeat of the same thing. Here are some examples that I'm going to do on the board. So the first example is y equals x squared plus x. All we're going to do is just look at this and just kind of analyze it, do a little mental exercise here. If I give you a value of x, are you going to get one value of y out? A single value. So I give you a single value of x, will you give me a single value of y? Let's try it. Let's just let x be 1. What would y be? 2? So you go from a single value to a single value, right? In a picture, this is what we just did. 1 got taken over to 2, right? It didn't go like this to 2 and 3, right? So that didn't happen. So we do so far look like we have a function. And then we could check another number just to make sure. Let's try a negative number. What's negative 2? Where does that go? So what happens if you plug negative 2 in there? You get positive 2, right? You square negative 2, that's 4, plus a negative 2, so take away 2, you get 2. So negative 2 goes to 2. Oh, wow, it went to the same place. Is that a problem? That's not a problem. Just as long as it didn't branch off to two or three different places. So it looks like this is okay. All right? How about part B? For part B, you have y is equal to square root of x plus 1. If I give you a value of x, are you going to be able to produce a single value of y? No? Which one? Give me an example that you wouldn't be able to do that. What's that? If you plug what? If I plug in 1 for x, I'm going to get what? Square root of 2, right? Ah, okay, so that, very good. I'm glad you brought that up. When we see a square root symbol, when someone presents to us a square root symbol, it is not plus or minus. Here's when it's plus or minus. If you introduce the square root symbol, right? So let's say we have something like this. That's an equation, right? And to solve that, we could take the square root of both sides. See, now I'm introducing it, right? And when I introduce it, I always have to look at both the positive and negative case. So this would be x is equal to plus or minus 2. Because I introduced the root, I have to look at both cases. If somebody presents you with the square root, we call this the principal root, and it's the positive case. Okay, so I'm glad you asked that question. This would still be okay, though. 1 goes to the square root of 2. That's okay. Are there any issues? Could we do that for every number? I mean, I could plug 3 in there. Where would 3 go? 2. Okay, so wait a minute. You're saying this works. What about this, then? What about negative 4? That would be imaginary. So I can't, right? I can't send this over, can I? Do you see that? Does that mean it's not a function, though? That does not mean it's not a function. What that means is this. Our domain is not everything, right? Because the domain is only the values that you are allowed to plug into the function without there being a problem. In this particular case, it looks like there are certain numbers I can't plug in, right? But all that does is changes what the domain is. It does not change the fact that if you pick a value that does work in there, that doesn't give you imaginary numbers like 1, it will go to square root of 2. And that if you pick 3, it will go to 2. So for every number that makes sense over here, it goes to one place. I'll scroll back up to the definition of domain, because now that we've talked about this, you can see what I'm saying. The set X, that is all the values for which the function is defined. That's the key. And for us in this problem, our domain, we're saying only the numbers that you are allowed to plug in that make sense over here. This negative 4 is not allowed in our domain because the function doesn't make sense there. Does that make sense?
So it'd be all negative numbers.
Well, we're going to have to investigate this a little bit further. Like, how would you determine the domain of this? You would have to look at this, wouldn't you? You need to guarantee me that that's not going to be negative, right? Okay, it's coming. We're going to look at that. That's going to be harder to do. But this does appear to be a function still. So B is a function. How about C? Y squared equals x plus 3. This is part C. If I give you an x value, will you give me one y value? No? Give me an example.
Well, regardless, you have to introduce the square
Okay, good. If x, let's go with something that's going to be cleaner. Make this a perfect square. So how about 1? Or 6 would have worked also. Okay, so if x is 1, what happens? This equation turns into what? Y squared equals 4. And now, David, this is where you would come in and introduce the square root on both sides, wouldn't you? So you would say y is equal to plus or minus the square root of 4, which is plus or minus 2, right? And now you have your branching out. Now what you're saying is that 1 goes to 2 and 1 goes to negative 2. Do you all see the difference? So because of that, this will not qualify as being a function of x. Because if I give you a single x value, you're going to give me 2 y values, and they're probably going to be different y values.
So it should only be 1 or 1.
Only to 1. Mm-hmm. I like to equate it to this. For a function to make sense, think about, have you ever seen, like at a gas station, they have those car washes that you can go drive through, right? And you go through and they're like $7, and you go in dirty and you come out freaking just as dirty because they suck, right? The ones that don't touch your car, the jet ones, you know what I'm talking about? The touchless ones are terrible. I'm sorry, I'm just, my opinion. If you like them, sorry. Exactly. That's exactly how I feel. So look, this is like a function, okay? Your car wash is a function. And it does something. You have an input, which is the domain, the cars, and then the output is, you know, clean car. So dirty car in, clean car out. But you never get dirty car in, 2 clean cars out, right? You figure out a way to do that, you'll be rich, right?
Then you're a magician.
Yeah, then you're a magician and you can make a lot of money that way. But you see, that doesn't make sense. Functions don't behave that way. You don't plug one thing in and get 2 things out, all right? Okay, what about D? X minus 1 equals y to the 4th. What do you think? You don't like the way it looks? Okay, so try something. Try what? Okay, you want me to plug in 1. If I plug in 1, where does it go? That's going to create, what, 0 equals y to the 4th? So what's y then? The only thing y can be then is 0, right? Are you following my arrows here, what I'm doing? Okay, so in my picture, if I drew my little domain and range thing, I would have 1 goes to 0. Is that a problem? No. Does that mean this is a function? We have to check a couple more, right? I mean, we may have gotten lucky on this one, we did. So let's try something else. 5? If we plug in 5, 5 minus 1 is 4. We get 4 is y to the 4th. So how do you get y by itself here? You got to 4th root it. So when we did square root, we did plus or minus, didn't we? When you do 4th root, do you do plus or minus? Yes. You have to do plus or minus also. So the 4th root of 4, that's, no one knows here off the top of their head what that is, right? You need a calculator for that. But do you agree I'm going to get 2 answers though? And they're going to be 2 different answers. So no go. Because 5 goes to 2 different places. It goes to the positive 4th root of 4, and it goes to negative 4th root of 4.
So is there like a common number that you can use that will basically split it up every time? Or, you know what I mean, like 0 works?
Nah.
Is there like a common number that will
No.
take out that if?
No, you just got to kind of play with it a little bit. What you may notice in C and D is that the power on y was an even power. And in that case, you know you're going to have to take a square root or a 4th root, so you know you're going to have plus or minus, so you know it's going to split into 2. That would be more of a key indicator. Now, let me just ask you, it's not up here, but let me ask you, what if this was a 3?
Then it would it be a plus or minus?
And let's get rid of the 1, because that one would give us pretty much the same result. Let me ask you what you would get right here. You go plug in 5 again. 5 minus 1 is 4. 4 would be equal to y cubed, right? And then to get y by itself, you would do what on both sides? Cube root, right? And when I do cube root, do I have to do plus or minus? No. Why? I don't know. They told me that. No. Because look, let's just go back to the idea of if I say x squared is equal to 4, right? That could be 2 or negative 2. 2 squared or negative 2 squared, right? But if I say something like x cubed is equal to 8, well, I should say it this way. This could be 2 times 2, or it could be negative 2 times negative 2, couldn't it? And the reason why that works is because a negative times a negative is positive. But if I do cubed, then the answer here, 2, 2, 2, right, that'll be 8. So 2 is an answer, but negative 2 couldn't be, because when you do that, you have 3 negatives, right? Negative times negative is positive, times another negative is negative, so you get negative 8, not positive 8. So because it's odd, you don't have to worry about the 2 scenarios. I hope that makes sense. So if we take an even root, 2, 4, 6, 8, 10, we always have to do plus or minus. If we take an odd root, it's not necessary. Which means what? If there's not a plus or minus, it goes to one place. There's only one answer, so this would be a function. All right, so this one would be. All right, let's keep it going here. All right, so we have a basic way of looking and seeing if something is a function, algebraically. Now, evaluating functions. You've done this, I'm sure, in the past. We're going to change our notation a little bit, and this is going to be an example. We used to say things like y is equal to negative 2x squared plus 3x minus 8. But now what we've determined is that a function? Well, we would check it and we would say, yeah, it's a function. For every x I plug in, I get one y. So we say, yes, this is a function. Since it is a function, instead of writing y, we write f of x. So we're replacing y with f of x. And what that does is it helps a person who's reading this. Okay, so when they're looking at this, they know it's a function. They don't even have to check it. That's already been done. So if someone writes for you, f of x equals this, there's no question that is a function. All right? So what we want to do is parts A through F is we want to evaluate the function. That just means plug things in, right? Just plug them in. The first few are pretty easy. They get a little harder as we go, though. So for A, we're going to do f of negative 2. And I like to do this one because let's see what different people get. I'll let y'all work it yourself. See if you can come up with the solution for this. And then I'll ask for a volunteer. And we'll see if we get people that have different answers. When you're done, raise your hand. I just want to see how quick people are. Okay. Okay, we've got 3 done, so 4 done. 5 done. Good. 6 are done. 7. 8, 9, 10. We'll wait on 2 more. Is that sign-in sheet around? Everybody got it? Okay. Thank you. All right, who wants to volunteer their answer? Go ahead.
Negative 22.
Negative 22. Does anybody have a different answer and feel really good that their answer is correct also and did not get negative 22? Anyone?
I got -6.
Negative 6, okay. Anyone else get something different? Okay, so let's do it. I have negative 2, and then I'm replacing every x with negative 2, right? So I'm going to replace the x with negative 2. That needs to be in parentheses and squared. Then I do plus 3, and I'm replacing the x with negative 2, so I'll put it in parentheses, and then minus 8. So I first do the exponents. Negative 2 squared, positive 4 times negative 2. Positive 4 times negative 2. Negative 8. Okay, positive 3 times negative 2. Negative 6, and then minus 8. So that's negative 22. So do you see where you got your, so we can all be happy. Where did you don't know where? No? Okay, so try and go back and figure out where you had it. I'm thinking maybe you did this came out to be a positive 8 in your work.
Yeah.
I think you may have, I don't know if you left that as a negative 4 or maybe you didn't see the negative out here, but it looks like you had positive 8 and it canceled with that and left you with a negative 6. So just be careful, right? Negative 22. All right, now let's do the next one, part B. We want to plug in negative x. So replace all of your x's with negative x. What would happen when we square the negative x? Becomes positive x squared, right? So in other words, that negative doesn't really matter because you're going to square it, it's going to go away. But you'll still have a negative 2 in front of it, won't you?
Yes.
Yeah? So the first piece here, the first term is negative 2x squared. This one does change though. So minus 3x, because that's multiplication, it's like a negative 1 in front of it, and then minus 8. That is what happens when you plug in negative x. Now, I'm going to box that. I'm going to come back to that because I want to ask you something about that after we do part C. Part C is asking us to find negative f of x. So what does that mean? Opposite. The opposite. We're going to use inverse later. It's going to mean something different. So opposite. It's the opposite of what f is. And when we say opposite, we mean opposite signs. We're just going to change the signs of everything. It's really like doing this. Negative 1 times the function, which means negative 1 times, what's the function? Negative 2x squared plus 3x minus 8. And then you distribute the negative through to each one of them, and it has the effect of changing all the signs. So 2x squared minus 3x plus 8. That's C. I have now a couple of questions to ask you. Is f of x the same as f of negative x? Are these two the same? Yes or no? This is what I'm asking you. Is f of x equal to f of negative x? Are they the exact same functions? No? Well, they both have negative 2x squared. They both have negative 8, but this one has positive 3x and this has negative 3x. So they are not the same functions. When this happens, because some functions do behave this way, when this happens, we call this function an even function, if that's true. All right? Now let me ask you this. Is f of x equal to negative f of x? So is the original function equal to this?
No.
No, they're not the same. All right? So I'm saying these are not true right now. Is f of negative x equal to negative f of x?
No.
No.
It doesn't do it.
Right? These two are not the same? They're almost the same, aren't they? Except that 8 at the back? It's different. And then, oh yeah, the negative 2. So those aren't true either. So what I told you is that there are some functions that you'll study later that this is true, and we call them an even function. And there are some functions that do this too, and we call those odd functions. Any of you ever take any trig classes in high school or anything? No? Trig? You remember the sine and cosine function? Yes? Sine of x is an example of an odd function. That means it behaves this way, and cosine is an example of an even function, which means it behaves this way. And so we're actually going to talk about even and odd, but it's just not, we won't deal with sine and cosine. That's going to be for pre-cal. All right, now part D. F of negative 3x is negative 2, negative 3x squared plus 3 times negative 3x minus 8. Did I get that right? Yes. So for this one, really just kind of want to make sure that you plugging things in appropriately. Anybody want to tell me what the first term is? Well, you know what? I'll ask. I'll give you a minute, and then I'm going to ask. I'm calling some people. Make it worth you having those name tags out. Does it seem like the class is getting smaller? It is, right? David, you look ready to go here. You want to just tell me what this first term is? Or were you not doing it? I can come back. I can do someone else. Go ahead. It's Jalen. Jalen, right? Okay. Go ahead, Jalen. What do you got? Negative 18x squared. Good. So the important thing is when you're squaring the negative 3x, you square the whole thing. That means you square negative 3, that's positive 9. You square the x, that's x squared. So this initial squaring here, this piece right here, gives you 9x squared. And then you multiply that times negative 2, which gives you negative 18x squared. That's the tricky part of the problem. The rest of it's pretty clean. This times this is what? Negative 9x and then minus 8. Okay. All right, now the next two are the ones that are more useful and going to be necessary that we can do this. Can anybody just explain to me what the difference is between this and what we've done so far? I mean, like we plugged in negative 2, we plugged in negative x, we plugged in... There's a plus sign, which means we're not plugging in a single number, right, or a single value. We're plugging in actually a sum of two things, right? So we have two terms we're plugging in instead of a single term. So we really have to be careful with the parentheses here. What would I write down here? Start with negative 2, then x plus 1 is what I'm plugging in, and I want to square that, and I want to square the whole thing, so I need it in parentheses, don't I? Plus 3, parenthesis again, x plus 1, minus 8. Can we all agree with that? Now you need to go through and actually simplify this. That means you have the pleasure of multiplying x plus 1 times x plus 1 and then distributing a negative 2 through. So what would, here's negative 2, just tell me what this would be. X squared plus 2x plus 1. But you need parentheses around that because the negative 2's got to pass through it. And then this 3 goes through here, so plus 3x plus 3, and then minus 8. And now pass the negative 2 through, and then we'll collect all like terms together. Okay. minus 2, and then we still have plus 3x, and then plus 3 and minus 8. Negative 2x squared. Okay, how many x's do we have there?
2.
Got 2 terms, so put them together.
Negative x.
Negative x
2.
minus 6, 7? 7. Minus 7. There we go. Anybody have any questions on that one?
So from that point, you wouldn't like factor it farther down or anything?
Nah. I mean, you could if it factored, but it's not asking you to solve this or set it equal to 0. It's saying what happens, we have a function f. What happens if you plug in something plus 1? Well, it'll just be that something squared times negative 2 minus the something minus 7. All right, now the next one is the most important one because it's the one that you're going to see a lot of in calculus and in this class. You have to be able to do this one. F. So f of x plus h. So this would be negative 2. Then in parentheses, what? X plus h. That's just like the x plus 1 we just did, right? But instead of 1, it's h. Plus 3 times x plus h. And then minus 8. So very similar to the problem we just did. You have to expand out the x plus h. Expand it times itself. So I'll let you do that on the side and on your own. But you would get this. I really do hope everyone is comfortable going from here to here. Right? Just remember you don't square each one, right? That's a big no-no. Don't just put x squared plus h squared there. Someone's going to do that. I know it happens. If I give a test and I give a problem like this and I put f of x plus h, I have never in my history of teaching ever had a class get that 100% correct. I've always had at least one student make this x squared plus h. It's always happened. So maybe this year is the year. I don't know. What do you think? Anybody want to volunteer to mess it up for me?
I got you.
You got it? You're going to mess it up?
Oh, I won't mess it up.
Oh, no, but I'm saying who's going to be the one that's going to put x squared plus h squared?
It's going to be me.
It's going to be you? All right, David is going to.
Sorry,
All right.
guys.
Sorry. All right, so now distribute the negative 2 through. What's kind of weird here is that you have to, when you go to collect like terms, it's kind of interesting because not a whole lot goes together. In fact, nothing here goes together.
Do you leave it like that, or do you move that
Yeah, I moved them
negative
around.
2? I moved the negative 2h squared over.
Oh, yeah, that's a good question. First, let's get to the issue of why you can't combine these together. They have to be like terms. To be like terms, they have to have same variables to the same powers. And they have to be exactly the same. So in order to put this together with anything, I need something with an x squared and only an x squared. To put something with this, I have to have an x and an h together. Don't have it. See? So nothing goes together. Now, the next question was, do we leave it like this or do we move it around? Everyone's heard of descending order before? You go highest power down. That's the protocol if you have one variable. If you have more than one variable, then you kind of lose the idea of descending order. So it really doesn't matter what order you leave it in. And even if I rearrange this, this would still be the same expression. So I'm just going to leave it like this. There you go. All right, you've got to be able to do that. All right, so this is just a definition. When you're looking at a function y equals f of x, and you're asked to evaluate it at some value like we just did, the thing you are plugging, it's a typo, this is supposed to say into,